Welcome back to another episode of Next Gen Ed 777. And that song was Space by Music Unlimited.
So here's the blue moon, like I promised you. It's very blue, isn't it? You know, it's a super blue moon, obviously, so it's a little extra blue, and yeah. No, it's not at all. So this is the actual picture. So yeah. Hopefully that got you, or hopefully it did it actually, but you know, if it did, just leave a comment maybe or not. You know, it's funny. I want to see if I got anyone, but yeah, blue moon does not mean it's blue actually. So it's just a regular kind of moon. So anyway, so let's talk about the video that we're gonna have today. This awesome video. It's about moon phases, obviously. So we're gonna be going over the different moon phases to start off, and then all the different kinds of moons associated with that, and including like supermoon, blue moon. I guess I'm gonna do a blood moon just so that we can get all the dates together. You know, that's technically an eclipse. To be honest, it's a lunar eclipse in the end. Yeah, so we're going to talk about those, and then we're talking about a little bit of astronomy behind astrology. Yeah, we're going to talk about solstices, equinoxes, and we're also going to talk about tropical astrology, along with precession and sidereal astrology and astronomical astrology, and I guess real sky astrology, which is very similar to that. And then we have natal charts, which is basically a regular chart from astrology, and then we have progress charts, which are basically charts that take into account that your age and everything, basically the progression of the planets as well due to that. And then to wrap things up, we're going to talk about calendars and how time and everything is kept track that way. Yeah, we're going to just briefly touch base with that. But yeah, so basically I just compiled a bunch of cool things into this episode, and this is going to be the part one. Part two is going to be really cool too. That's going to have Hecate and werewolves, so those are going to be the main focus, but it's basically about gods and goddesses, the moon, and then also the werewolves. So I just kind of picked Hecate in particular, so I'll go more into that in part two about that. But anyways, so part one. In astrology, the moon is associated with emotions, intuition, and the feminine energy. The different phases of the moon are believed to have different effects on our emotions and behavior. The zodiac sign associated with the moon is Cancer. And then, just like all the other ones that are associated with a planet, this one's associated with the moon. As a whole, the moon has been a symbol of femininity, intuition, and the subconscious. It has also been associated with various deities and goddesses throughout history. The phases of the moon are caused by the moon's orbit around the Earth, along with the Earth's orbit around the sun. So basically, you've got these two effects going on, and once you add them both together, you're going to get what we see, the moon phases. So basically, that's going to be based off of superposition, which is a mathematical term, and I'm going to go into that in our next video as well. But anyways, the moon takes about 27.3 days to orbit the Earth, while the moon takes about 29.5 days to go through its, phases, full moon, new moon, and everything, just basically a new moon to another, or full moon to another full moon, one complete period. Anyways, lunar phases. In many cultures, certain lunar phases were believed to be lucky or unlucky. For example, it was believed that the waxing moon was a good time to start new projects, while the waning moon was a good time to finish old projects. So now let's go over all the moon phases in depth in particular. So we have our new moon. So this is the phase of the moon when it is completely dark and not visible from Earth. It occurs when the moon is positioned between the Earth and the sun. So usually you see this moon during the day, weirdly enough. So the new moon is during the day. Not as eventful. It's not like a nighttime thing in the end, but it's kind of cool. You can see it during the day. Anyways, in astrology, this is a time for new beginnings, fresh starts, setting intentions, and planting seeds for the future. The next phase would be waxing crescent. This is the phase of the moon when it starts to become visible again after the new moon. It appears as a thin crescent in the sky. This is a time for taking actions towards your goals, making plans, and building momentum. Then we have first quarter. This is the phase of the moon when it appears as a half circle in the sky. It occurs when the moon has completed a quarter of its orbit around the Earth. In astrology, this is the time for taking action, making decisions, and moving forward with plans. Now we're on to waxing gibbous. This is the phase of the moon when it is almost fully illuminated, but not quite. So it appears as greater than a semicircle and less than a circle. So it's like just almost a circle, almost full moon. In astrology, this is time for refinement, making adjustments, and fine-tuning your plans. So now we have full moon. So this is the phase of the moon when it is fully illuminated and occurs when the moon is on the opposite side of the Earth from the sun. So full moon's always going to be visible during the night. So it's only going to be visible because it's on the opposite side. Anyway, so in astrology, this is a time for accumulation, manifestation, and the peak of energy. It is a time to release what no longer serves you and to express gratitude for what you have. The full moon has been associated with various myths and folklore throughout history, including werewolves and much more. In many cultures, the full moon was believed to have magical powers and to be a time of heightened emotions and supernatural activity. It is also believed that babies are born more often on full moons, practically inducing labor in pregnant women. I'm a full moon baby, to be honest. I guess there's some sort of credit to all that. But however, scientific studies have not found a correlation between people's birthdays and dates of full moons. Nevertheless, the moon does influence certain animals and their reproductive patterns. Some marine creatures, such as coral and certain species of fish, synchronize their spawning with moon phases. In particular, sea turtles often lay their eggs during specific lunar cycles so that their young will hatch on full moons. The correlation between animals and moon phases is complex and varies across species. And this is going to be in another later episode as well, so stay tuned for that. Now we're on to waning gibbous. This is the phase of the moon when it is starting to become less illuminated. Basically just coming out of a full moon. So it's going to be a full circle and it's going to be shrinking a little bit. So it's going to be almost a full circle. And then in astrology, this is a time for reflection, letting go, and releasing what no longer serves you. Now we're on to third quarter. This is the phase of the moon when it appears as a half circle in the sky and is going to be on the opposite side of the first quarter phase, obviously. So in astrology, this is a time for releasing, letting go, and surrendering to the flow of life. And then to wrap it up, we have waning crescent. So this is the phase of the moon when it is almost dark again and appears as a thin crescent in the sky. In astrology, this is a time for rest, reflection, and preparing for the next new moon. As you may have noticed, the names started off with waxing, then transitioned to waning. This describes the increase and decrease of the moon's illumination. The term waxing comes from the Old English word wuxan, meaning to grow or to increase. It is used to describe the moon's illumination when it is growing larger from one phase to the next. The term waning comes from the Old English word waning, meaning to decrease or to diminish. I probably said the Old English wrong, but whatever. Anyways, during the waning phases, the moon's illumination gradually decreases as it moves towards the next new moon. The term gibbous originated from the Latin word gibbosus, which means humpbacked or protuberant. Okay, well, anyways. The word describes the appearance of the moon when it is more than half illuminated, but not full, forming a round bulge shape, almost like a humpback, you know? Now, before we move on to the different full moons and new moons, get out of moon phases, I just want to reiterate, just like at the beginning of this video, that the dark side of the moon experiences the exact opposite phases that we see. So yeah, just the exact opposite version is on the other side, obviously. So now from that, we're going to go on to all the different full moons. Blue moons is our first one. So a blue moon is commonly defined as the second full moon occurring within a single calendar month. While rare, they can happen approximately once every 2.7 years. The term blue doesn't refer to the moon's actual color, but rather signifies its rarity. The origin of the term blue moon is somewhat uncertain. It is believed to have evolved from the phrase blue moon in Old English, which meant betrayer moon. This referred to an extra moon that could betray the usual lunar cycle of seasons. So typically, like we said at the very beginning of that, monthly blue moons is the modern day interpretation of blue moon, but back in the day they had seasonal blue moons, which was actually the third full moon if there were 4 that season. But yeah, and then in 2018 we had 2 blue moons. So we had a blue moon in January and blue moon in March. And this was due to the fact that February has 28 days, which makes total sense. The lunar cycle, the moon phase period is going to be 29.5 days. So it makes sense that having February in the middle kind of like evens things out. So you're going to have a second blue moon actually. So funny how that worked out in 2018, but February makes things a little iffy then. But yeah, and our last blue moon was the super blue moon on August 30th. And then as you can see, we got this fancy lunar calendar. We got this for last year and then also this year. But as you can see, they both are going to have moon eclipses, lunar eclipses, and also solar eclipses on here too. So solar eclipses happen when new moons are present, and then lunar eclipses will happen when it's a full moon. So a lunar eclipse will be a blood moon, give or take. So give or take. But yeah, we'll talk about that in just a second. But yeah, that's the 2023 lunar calendar. And then we have our 2024 lunar calendar here as well. So yeah, if we check out this year's calendar, we're able to see that it doesn't have any monthly blue moons. There's not 2 full moons in 1 month, unfortunately. So, but if we're able to break up the year via solstices and equinoxes, the seasons, in other words, we're able to see that we're going to have a seasonal blue moon on August 19th. So that's going to be the third one of that season, summer. And then weirdly enough, our next monthly blue moon is not going to happen until May 31st of 2026. So 2 years down the road. So yeah, this is going to be the second one of the month then. And now on to blood moons. Blood moons, they're technically lunar eclipses, so we'll go into further detail later in a different video. However, they're also full moons, and I figured might as well give you some dates, while we're at it. But anyway, so blood moons, also known as total lunar eclipses, occur when the Earth aligns between the Sun and the Moon. This will cast a shadow onto the Moon's surface that will be red in the end, at least if it's a total lunar eclipse. During this alignment, the Moon can appear reddish or coppery, which gives its name the blood moon. Now as we look at this diagram, we can see this shadow of a cone right here, right in the middle. Now that's basically the umbra. However, in this diagram, the red is actually refracted off the atmosphere of the Earth, and it's going to be causing some red light, in fact, to be moving towards the shadow. So it's refracted towards it, and that's why we're able to see it as red. The umbra is the shadow, and the shadow actually extends into the red right here. So it's technically an eclipse, total eclipse, when it goes through the umbra. So now if we look at this outside portion, which is the penumbra, that's going to be where it's partially eclipsed by the sun, where it only has some of the sunlight. So that is a penumbra eclipse. However, a partial eclipse is going to have some red to it. So it's going to go through that umbra area and be part of the penumbra and the umbra portion. So it's going to be on the border, hence partial lunar eclipse. So a full lunar eclipse is when it's completely red. So now if we look at this picture here, Basically, it's a series of photos of a moon as it went through a total lunar eclipse. So you can see there's some prenumbral and partial lunar eclipses in this as well as it enters a total eclipse. And then as we put it over here, we can see that it's almost like it follows the light then as well. Unfortunately, I do have to point out that all these are full moons. So the photo that was taken here, it must have had a cloud in the way or something. So let's fill those in real quick, even though it's probably not as accurate as possible. But basically, it's going to be like that, where it goes from light, red to light. So if we check out last year's lunar calendar, we can see that we had a prenumbral eclipse on May 5th, and then we also had a partial eclipse on October 28th. Now if we check out this year, we'll see that we're going to have a prenumbral eclipse on March 25th. And then we have a partial lunar eclipse on September 18th, followed by an almost lunar eclipse on October 7th. So it almost touches the shadow, it just barely doesn't graze it. So let's kind of have that asterisk there. But yeah, it's kind of cool because it happens the next month. So it's almost like a blue moon version of lunar eclipses. It happens right after itself. So very rare. So, but yeah, it almost hits it. So if we touch base real quick with solar eclipses while we have our lunar calendar present, we'll just go over the dates, and if you really want to learn more, I'm going to have a future video about eclipses in a bit. But yeah, if we look at last year's lunar calendar, we see that on April 20th, there was a total solar eclipse, and then we had on October 14th was an annular eclipse. Annular means the moon was a little farther than normal, so it doesn't cover up the sun completely. And there's also partial, where it partially hits it, and then hybrid is a mix. And then now if we look at this year's, we have one coming up on April 8th. That's going to be a total solar eclipse. And then we're also going to have one on October 2nd. That's going to be an annular one.
Now on to harvest moons. Harvest moons are the full moons that occur closest to the autumnal equinox, which is September 22nd, just like we talked about. These moons rise soon after sunset, providing abundant moonlight during the harvest season. The name harvest moon originates from the extra light it offers, aiding farmers in harvesting their crops.
The one last year was
on September 29th, a little while ago, and then this year is going to be on September 17th. Now on to hunter's moons. Hunter's moons are the full moons following the harvest moon. They are called so because they traditionally provide additional moonlight for hunters to pursue game even after sunset, and for the most part this is only for humans. The full moon may influence some aspects of animal behavior. It is just one of many factors that shape the complex interactions between predator and prey. Other factors, such as the availability of food, mating cycles, in other words, weather conditions, the seasons, and the presence of competitors also play significant roles. In the end, full moons do not invoke predatory instincts in animals. Not only was this a time used by people for hunting, but also for slaughtering and preserving meats. And just recently we had a hunter's moon, which was on October 28th.
Now this year's is going to be on October 18th.
Another thing to note about this is that every 3 years, the harvest moon and the hunter's moon are the same. Mainly because the hunter's moon is defined as it's in October, and harvest is the one closest to the autumnal equinox. Sometimes it's the same. Here's the meats.
And now on to supermoons. Supermoons are full moons that coincide with the moon's closest approach to the Earth in elliptical orbit, known as perigee. As a result, they appear larger and brighter than usual. Supermoons can occur a few times a year and offer a mesmerizing sight in the night sky. Last year we had 2 supermoons that resulted in our super blue moon, which we'll talk about in the next section. Yeah, we had a supermoon on August 1st and another supermoon on August 30th. This year, we're going to have 2 supermoons around that time too. However, it's going to be on September 18th and October 17th. So now let's define what perigee is a little bit better. And while we're at it, we're going to define what apogee is. Perigee is, according to NASA, going to be 226,000 miles, which is 363,300 kilometers. And on the other hand, apogee is going to be 251,000 miles and 405,500 kilometers. So the moon isn't
always at these distances when it's a full moon or new moon. It's kind of hit or miss a little bit. So, I mean, of course, they're not going to hit these on the dot. So how we define perigee and apogee is that they have to be within 90% of those distances in the end. So 90% of the farthest distance and 90% of the closest distance in order to be still considered that. So that's why we're able to have super blue moons in the end, where it's a supermoon right after a supermoon. Now, the moon's proximity to Earth during perigee can have an influence on Earth's tides. The gravitational pull of the moon, along with that of the sun, contributes to the rise and fall of the ocean's tides. During perigee, the moon's gravitational pull is slightly stronger, leading to a higher than average tides known as perigean tides or perigean spring tides. This can result in raising the tides by 2 inches. This has been apparent during the super blue moon on August 30th, which was when Hurricane Idalia hit Florida and the East Coast. It actually increased the intensity of the storm during the night. However, when it came in the morning, it actually settled things down pretty good. You know, if 2 inches were risen, well then that water must have been displaced somewhere. So once the moon, or aka the night, passed over, during the day, the tides were settled, per se. So now that we paved the road with supermoon, let's talk about super blue moon. So obviously, it's just the combination of blue moon and supermoon. So it's just a supermoon that happens 2 times in a row in 1 month. I guess typically it's just a month for this one. So our last one was August 30th. So there's a supermoon on August 1st and then August 30th. And then the next super blue moons will occur in a pair, actually, in January and March in 2037. So a while from now. So, but it'll pair it up like that just because there's February in the middle. Now, if we analyze this diagram, but from a super blue moon perspective, we're going to see that there's going to be 2 supermoons in a row. However, they're not going to be in the same spot just because the orbiting period and the lunar phase period are off. So the periods are off, so it's not going to be in the same spot. And that's all due to the fact that a supermoon is going to be a full moon. So it's going to be a full moon right here, and then next time it's going to be a full moon, it's going to be in a different spot. So in doing our analysis, we're going to have 29.5 days as our lunar phase period, and then we're going to see how many degrees that comes up with in the end. So for every period of rotation, you're going to have 27.3 days. So we're going to be able to cancel days in the end. And then we're going to have for every 1 period, we're going to have 360 degrees. 1 full rotation. Then periods cancel. And then we multiply everything out, we're going to have 389.01 degrees. And that's going to be equivalent to 1 rotation. And 29.01 degrees. So it's going to go past it about like 30 degrees. Now this is a rough estimate just because Kepler's law states that the area that it sweeps out is going to be a consistent number in the end. So pretty much it's going to be going faster over here and slower at apogee. However, for the most part, this is a pretty good estimate in the end. But yeah, it's not accurate. We'd have to use Kepler's law to be accurate at that, but it's a good estimate. And then one thing to note before I move on is that perigee is going to be 14% larger in the night sky and then 30% brighter in the night sky compared to apogee. So 40% larger of a moon compared to apogee. That's kind of cool. Now let's dive into micromoons. So just like we talked with perigee, it's just going to be apogee. So it's going to be the farthest distance. And this term is actually going to be used to describe both new moons and full moons. So a great example of this is going to be, just like I discussed earlier with the solar eclipses, the annular solar eclipse. So it's going to be basically not fully covering up the sun, but it's going to be covering up most of it, you know. So it's just going to have this outer ring, just like you can see right now. But yeah, that's a great example of a micromoon. It's covering up most of the moon, but it's missing some of it because it's further away. When it's in perigee, it covers up all of it, pretty much, just like so. But we're focusing on micromoon. So yeah, annular is going to be micro. Now our last micromoon was on August 16th, which totally makes sense because that coincides with the super blue moon. It's going to be in the middle of all that. And now if we go on to this year's calendar, we can see that February 24th is going to be a micro full moon, and then March 25th is going to be a micro full moon as well. And then we're going to also have a micro new moon on October 2nd. And now we're going to discuss basically different new moons. We just discussed a bunch of different kinds of full moons. We're just going to discuss the new moons. These are as widely known and recognized, but might as well discuss them, I'd say. So the first one is going to be black moon. The term black moon is used to describe a rare phenomenon that occurs when there are two new moons within a calendar month. This is similar to a definition of a blue moon. Unlike the blue moon, the black moon is not visible since it is essentially an absence of moonlight. Now our next one is going to be on November 30th, 2024. So now we got next is super new moons. A super new moon occurs during perigee pretty much. So it's just like a super moon, however it's going to be a new moon version of it. This is going to cause it to be slightly larger and brighter. However, the difference in size and brightness may not be as noticeable as during a supermoon. Now, the next one we got is going to be on February 9th of 2024. And then we're also going to have one on March 10th right after that, and then April 8th. So there's going to be 3 supermoons right in a row. And then that makes sense because we're going to have micro full moons in between that on February 24th and March 25th, just like I discussed a little bit ago. So yeah, basically we're going to have 3 super new moons in that little area, which is kind of cool. And then to wrap it up, we got super black moon. So this is going to be the combination of black moon and super new moon. So it's basically the equivalent of super blue moon, but the new moon version of that. So it's going to be 2 consecutive perigees, in which it's going to be a new moon, 1 month as well, just like a blue moon is. And then our next one's going to be on August 31st of 2027, though. So a ways from now. Now that we've extensively gone over all the moons, I mean, we did a little bit of astrology at the beginning as well, but we can go into astrology itself right now and then talk about tropical and sidereal and basically all the other things dealing with it. But in order to talk about tropical and sidereal, we're going to have to go into some other things. So we're going to have to give you some background in the end. So we're going to have to talk about equinoxes and solstices next. So first, though, we have to discuss what a subsolar point is. The subsolar point, in terms of the Earth, refers to the exact location on the Earth's surface where the sun is directly overhead at a given moment. It is the point at which the sun's rays are perpendicular to the Earth's surface, resulting in maximum solar intensity. So basically it's going to be perpendicular to the tangential plane, almost like a tangential line, but a tangential plane of the surface. So if you think in count 3 terms. Now, as the subsolar point moves north and south, it's going to dictate the seasons, pretty much. So as it reaches a certain point, we're going to call it a solstice or equinox in the end. And so now let's go over all the solstices and equinoxes. As you can see from this lovely illustration that we have from NASA, it's got both the equinoxes in there. And it's also got this loop that we call the ecliptic, of course. So that's the movement of Earth around the sun. And then it's missing the solstices, so let's fill that in right now. So we got our summer solstice right here, and we also got our winter solstice right here. So now, if we like the other names, we got a March equinox, which is actually just the same thing as a vernal equinox. And we also have our September equinox, which is our autumnal equinox. The same thing could be almost said about the solstices as well. They could be called the June solstice for the summer, and also the December solstice for winter. So if we put all that together, we're going to basically start with our vernal equinox, move to the summer solstice, then have our autumnal equinox, and then finish it up with the winter solstice, and then back to the vernal equinox again. Repeat. So yeah, that's the illustration. So let's start off with the vernal equinox. This guy right here. The vernal equinox, also known as the spring equinox, will happen on a day between March 19th through March 21st. And this will happen when the subsolar point crosses the equator, ascending north. On this day and night are approximately of equal length in most locations on Earth. This year, the vernal equinox will occur on March 20th. And when we refer to things in the southern hemisphere, this will be the mark of the autumnal equinox. Now we got the summer solstice next. It's going to be this one in the sequence, as you can see. And now the summer solstice will happen someday between June 20th through June 22nd, and is when the North Pole is tilted towards the sun, making it the longest day and shortest night of the year in the northern hemisphere. By definition, it is where the subsolar point touches the Tropic of Cancer before descending south. So now it uses Cancer just because June 21st is the beginning of Cancer. This year, the summer solstice will occur on June 21st. In the southern hemisphere, this will be the mark of the winter solstice. Up next, we got the autumnal equinox. So as you can see, this is the next one right here. Now, this will take place someday between September 21st through September 23rd. It is when the subsolar point crosses the equator descending south. So again, just like we saw with the vernal equinox, this is when the day and night are approximately equal in length for most parts of the world. This year, the autumnal equinox will occur on September 23rd. In the southern hemisphere, this will be the mark of the vernal equinox. And then to wrap it all up, we have our winter solstice. So it's going to be this one in our whole sequence now. Now the winter solstice will take place someday between December 21st through December 23rd. It is when the North Pole is tilted away from the sun, resulting in the shortest day and longest night of the year in the northern hemisphere. By definition, it is when the subsolar point touches the Tropic of Capricorn before ascending north. Now this makes sense because Capricorn starts on December 21st. Anyways, this year the winter solstice will occur on December 22nd. In the southern hemisphere, this will be the mark of the summer solstice instead. So to wrap it up, let's just talk about the obliquity of Earth real quick, or in other words, the tilt of Earth compared to the ecliptic. So that's going to be 23.44 degrees, and that's going to range from 22.1 to 24.5 degrees. So currently it's 23.44, and it's going to stay that way for a long time, just because precession is a very, very slow process. Now, the funny thing about Uranus, and it's not its name, obviously, so ha ha ha, joke's been beaten to death 1,000 times. So, but anyways, the funny thing about Uranus is that it's got a 98-degree tilt. So it's going to look more like this. So an issue with that is when it's going to have its summer and winter solstices. So both these scenarios are when the pole is pointed towards the sun or away from the sun. So it's either going to get sun all day long until it changes seasons, or it's going to get no sun all day long until it changes seasons again as well. So yeah, it's kind of the weird thing about Uranus. It's not fun to live there. But yeah, that's a funny fact in the end. So now that we've gone over solstices and equinoxes, we'll be able to talk about tropical astrology that much better. But before we do that, I do need to make a disclaimer first. Now, different kinds of astrology that we are not typically used to may offer insights or perspectives that could be helpful or just interesting. It's always worth keeping an open mind and exploring different systems to see what feels best for you. There are even more types than that will be discussed right now. This is mainly to inform you and to mainly go through the astronomy associated with some of the most popular forms of astrology. Regardless, there's plenty of good material that we'll be touching, such as time, the calendar, and the night sky that a lot of people may not know about. So enjoy. Tropical astrology. Now, tropical astrology is the most commonly used type of astrology in the Western world, and is the system that is typically used in mainstream horoscopes and astrological readings. It is based on the tropical zodiac, which divides the ecliptic into 12 equal signs of 30 degrees. The starting point is the vernal equinox, and it is not directly linked to the positions of the constellations. To account for this, the tropical zodiac used in astrology is based on the seasons and the positions of the sun relative to the Earth's orbit. It keeps the zodiac signs aligned with the seasons, even though the position of the constellations may change over time due to precession. Since tropical astrology is directly tied to the position of the sun relative to the Earth's orbit and the seasons, The tropical zodiac remains valid for astrological purposes. And now we're on to Sidereal Astrology. So just like we had with tropical astrology, we have to do some background with sidereal astrology. So kind of stinks, but it is what it is. I'd rather go through it properly than improperly. Anyways, so precession. We have to talk about precession. So precessional motion refers to the slow, cyclical movement of the Earth's rotational axis over an extended period of time. This phenomenon plays a significant role in altering Earth's orbital characteristics, including its orbital period of approximately 365.24 days. Now, precession is innately the gradual wobbling motion of the Earth's rotational axis caused by external force exerted by other planets on the planet. This motion creates a slow conical rotation on the Earth's axis, similar to the way a spinning top wobbles in its loose momentum. The primary cause of precessional motion are the gravitational forces exerted by the Sun and the Moon on the Earth's equatorial bulge. These forces include a torque that acts to reorientate the Earth's axis over time. In the end, the precessional motion of the Earth causes the sidereal year, one orbit relative to fixed stars, to be slightly shorter than the tropical year, which is one orbit relative to the seasons. The sidereal year is approximately 20 minutes shorter than the tropical year, basically your typical year. So just like what we saw with equinoxes and solstices, we had to talk about subsolar point before we gave those definitions fully. We have to talk about the celestial sphere before we fully dive into precessional motion and precession itself, So yeah, basically we got to talk about this guy right here. So this is the celestial sphere, and it's basically made by this infinite sphere of all the stars and planets that are seen from Earth projected onto it. So basically it gives a map of the night sky in the end for us. So it's going to have this greater circle on it called the celestial equator. It's basically the same thing as our equator projected onto the celestial sphere then. So basically we share, or Earth shares, the same equator as the celestial equator. They're just different spheres in the end. And then it also shares the same poles in the end. So the North Pole and the North Celestial Pole are going to be the same. So the way we measure and navigate the celestial sphere is going to be via the vernal equinox. So it's going to be 0, on our celestial sphere. So, of course, the vernal equinox moves a bit, but it's very slow, and for our sake right now, it's stagnant. But it's basically 0, in the end. It is our origin. It's going to be measured by declination, which is going to be in degrees. So the North Pole is positive 90 degrees, and the South Pole is negative 90. And then equator is just going to be 0 degrees. And that's going to be basically north-south, up and down, and it's basically going to be latitude, when I think in terms of a globe. And then we also have right ascension, which is going to be measured from the east. So it's measured eastward just because that's where all the stars, that's where the sun comes from. Just makes things a little bit easier. And that's also measured in hours, which kind of makes sense. So one full circle around is 24 hours. So it's measured in hours. And of course, it's going to be east and west, and it's going to be longitude pretty much, if you want to think in terms of a globe then as well for that one. Now, unfortunately, this is kind of a bad reference frame, just because the celestial equator and like the vernal equinox kind of moves. And on top of that, the celestial pole and North Pole are actually going to move through the night sky as well. So pretty much everything's moving and nothing's stationary in the end in terms of precession and everything. However, the celestial sphere is actually really good from an analogous standpoint or like a practical standpoint, and here's, as you can see, why. Here's a little star trail. As you can see, that here's Polaris in the middle. So and all the stars are going to be rotating around it. So you're going to want a frame of reference where Polaris has got one of the axes pretty much. And so it's just going to be a little bit easier to map everything out, and it's a little bit more chaotic if we move our reference point a little bit further down into like the middle of Draco, which is how we really should want it from a mathematical standpoint. But from a stargazer standpoint,
it's a nightmare. It's a nightmare to map everything out. So we use the celestial sphere just like this. It's actually a little bit more practical. So it's a bad reference frame though in terms of math and figuring out all this precession stuff. But we'll push through it all.
In doing so, we're going to start off with some star maps. So for this first one, it looks a little weird. It's a star wheel is what it's called. So basically what you're going to do is you're going to start off with these two wheels and you're going to cut them both out. So you're going to have two circles and then you're also going to cut out the middle interior of this right side one. And so basically you're going to cut out to your latitude. And so once you do that, you can actually line up the date and the time together. So basically you figure out where all that stuff lines up, and then in that hole that you just cut out for the latitude, it'll have what you see in the night sky. So now that we've gone over the mechanics of the star wheel, let's just go over the star wheel itself, the star map of it. So let's first look at this yellow circle that's going around. So this is going to be the ecliptic in the end. So first thing first, it's going to start with Aries, and it's going to go into Taurus, and it's going to touch the tip of Orion real quick. And then it's going to go into Gemini. It's going to go into Cancer. It's going to go into Leo. And then it's going to go into Virgo. And then it's going to go into Libra. And then it's going to go into Scorpius for a little bit. And then it's going to go into Ophiuchus right after that, which is almost like Scorpio. And then it's going to go into Sagittarius right after that. And then it's going into Capricornus. And then Aquarius. And then on to Pisces to finish it all off. And then we also have this white glob here. So it's going to be the Milky Way in the end. So sometimes they have it in there, sometimes they don't. So either or is fine. As long as it's got all the constellations, then it's technically a star map. So that's the star wheel, and so pretty much keep in mind that this is only for the northern hemisphere. So if you want a southern hemisphere star wheel, it's going to be a lot different. Still sort of have some of the same mechanics and everything, however, it'll look a little bit different. So now that we've finished the star wheel, let's move on to a more conventional star map, which is this rectangular star map. So I got this one in particular from Wiki Commons. So if you want to check out the link, it's going to be in the description or even right here. But anyways, so as you can see, it's still got the ecliptic, just like the last one. So instead of it being a circle, it's going to be this sinusoidal function. But actually, it goes from right to left, just because, you know, as you can see, it starts off with 0 hours, and then 24 hours is going to be on the very left. So, but as we go through this ecliptic right here, we can see that it hits all 12 signs, and then also Ophiuchus, and then grazes Orion a little bit as well. So yeah, it's exactly the same. However, things might be a little bit bigger and smaller just because it's a rectangular coordinate system. And so the north and south celestial poles are going to be a little inflated.
Nevertheless, the constellation boundaries that are seen here are recognized by the International Astronomical Union, or IAU. Now, these constellations use right ascension and declination, which is why they are square-like, and so it might not be the best to describe whether things are in Libra or Aries or whatever constellation, but nevertheless, it is the most used and agreed upon coordinate system.
So now that we've gone over star maps, let's dive a little bit more into precession itself. So as you can see with this picture, we have the ecliptic going around the Earth, and then we have this coordinate system right in the middle, X, Y, Z, and Z is going to be pointing towards the North Pole, and its negative direction is pointing towards the South. Now if we rotate the coordinate system in the Z-axis, we will have a new X-axis and a new Y-axis defined. So now it's spinning in this direction, and this is going to be precession in the end, pretty much. So, and this is the reason why we go through all the different zodiac signs when we go through precession, as we go in retrograde as well. And since it goes retrograde, it actually goes backwards from this purple arrow. It's going to go in the negative direction. So now that we have the world experience precession, let's now tilt the axis. So we're going to tilt the Z-axis.
So in doing so, we'll be rotating the coordinate system essentially around the x-axis. And we're going to cause this blue arrow, and it's going to be called nutation. We experience nutation, oscillate every once in a while, and I'll explain that in a second. And then now we'll implement spin. So we're going to have worlds spin around the z-axis. So we're going to have 3 angular velocities define this coordinate system. So it's going to have nutation, precession, and spin. So now let's analyze this steady precession equation. I don't have to know too much about math, but this is going to be one equation. You should have 3 total, so 1 for each axis. And that's going to be the sum of the torques or moments around the x-axis, y-axis, or z-axis. So there's nothing happening in the y-axis or z-axis, mainly because there's nothing there, but you're going to have a moment or torque in the x-axis provided by the sun, the moon, and other celestial bodies due to the Earth's equatorial bulge. And that's why we only have one equation. And now if we focus our attention on the diagram above, we can see that we have our spin and we have our precession. And then we also have nutation right here, this N. I bet as a little circle because basically it's going to oscillate every 18.6 years. That's going to be due to the moon's orbital nodes. Now, naturally, the nutation angle is going to range from 21.4 to 24.5 degrees. Now, that period is going to be 41,000 years. So the main difference is that you have these little tiny cycles. However, the position of those cycles will change, and then that's why we have this giant period. And then one last thing to note is that the nutation cycles coincide with the precession of the moon's orbital nodes, which are where the moon crosses the ecliptic. So basically the moon will go above the Earth, north of the Earth, and then the moon will go below the Earth or south of the Earth. And it just so happens that the moon's nodal precession is in fact 18.6 as well. And one more thing to know about precession, it would be orbital precession. So a type of precession in the end. So it's the whole orbit or elliptic precessing itself. And so this is also known as aspidal precession. Now, orbital precession basically is how the Earth is viewing everything through its orbit. So as the orbit precesses, it moves around the sun, then it changes how we view everything. And so the apsides, or the orbital points farthest and closest to the object being orbited, or the sun in our, they are going to move and rotate around the sun. And then so you have the apophysis, which is the farthest, and the perigee, which is the closest. Now, orbital precession affects celestial observations by causing the orientation of an object to change over time due to gravitational forces exerted by other celestial bodies. This phenomenon can have several implications for celestial observations, such as changes in perihelion and apophelion. Basically, perihelion is the closest an object in the night sky will get to us, and apophelion is the farthest an object will get to us in their own orbit. And then there's also equinoxes and solstices that are affected, and then satellites in orbit. Now, this phenomenon does not significantly alter Earth's axial precessional period, but it does impact the orientation of Earth's elliptical orbit over longer timescales. The combined effect creates a more complex pattern in the night sky over thousands of years, affecting the position of the stars and constellations as observed from Earth. So let's go over how this now looks in the end. So if we go back to that picture we had, however, we're going to put the sun in there too now. And so we're going to start off with the vernal equinox. So now the vernal equinox has the sun in Pisces. It's going to move to Aquarius. So it's going to go in retrograde. And now if we see the vernal equinox is now going to turn into the summer solstice. And then it's going to cross back during the autumnal equinox. And then it's going to go into the winter solstice. And then it's going to return back to the vernal equinox. So now that we've gone over a full year, fully defining the solstices and equinoxes, let's now take into account all the ages. Every time we look at these ages, we're measuring from the vernal equinox. Because obviously we need to pick a point in our orbital path to map things out. So we pick the vernal equinox every time. So as you can see, we're going to start on Aries, So the reason why we're starting off in Aries, because that's about 2,000 years ago. We're currently in the age of Pisces, and then we're on the cusp of getting into Aquarius. And so, as you can see, this is going to be going retrograde, going backwards through the zodiac signs. And so we're going to start off with Aries, and then we're going to go into Pisces. Like I said, that's our current time right now, the current age. And then we're going to go on to Aquarius, and then we're going to go on to Capricornus, to Sagittarius, Scorpius, Libra, and then we're going to go on to the age of Virgo, which is going to be the opposite of what right now is. So we're going to be halfway through it. And then we're going to go on to Leo, Cancer, Gemini, and then we're going to wrap it up with the age of Taurus, and then back to Aries. So now that we've gone through all the ages and shown how it goes in retrograde, let's now go through the North Star and how it traverses through the night sky. So weirdly enough, it's not stationary. None of the stars are really, and as I showed, so pretty much precession means we're all rotating around Draco in the end, just like so. So we're really rotating around there, even though the Earth is spinning around the North Pole. And so we can see that the North Pole is going to traverse all the way through the night sky. So right now, the North Star is going to be Polaris, and that's going to be in the Little Dipper. So as the North Star traverses through the night sky, it's going to be going through Ursa Minor, obviously, the Little Dipper, and then it's going to go to Cepheus, Cygnus, Lyra, which has Vega in it, so it's almost considered Vega is going to be the North Star at that point. And then we're going to Hercules, and then we're going to go through the tail of Draco at the very end and hit Thuban. And then just keep in mind that the Earth's North Pole and the North Celestial Pole are going to be the same. So now, if we go back to how I had it with all the years in there, you can see how it chronologically goes through the cycle. So it starts with 2000 BC pretty much for Aries, and I made that one a little bit shorter because Aries is a little smaller and just kind of how it goes.
So in wrapping all that up, we can see that each age is 2,150 years.
And so this is actually divided up perfectly even amongst 12 zodiac signs. So in the end, this really isn't correct. Each constellation is of different size in the end. They're not all the same. And because of this, basically the degrees that we're working with between each different age of the North Star is not accurate. So in using the degrees of how they're actually measured in the end, and keep in mind this is kind of a rough estimate, just because we don't know the specific boundaries between constellations. It's a little bit kind of vague, and you kind of have to fill in the gaps on that one. But anyways, so as you can see, Aries has a little smaller one. It's like 18. Pisces has 42 degrees. Scorpio has a 10-degree window, just because it also has Ophiuchus as well. So there's also another sign in there. And as you can see earlier in the video, there's also Orion as well, with the whole Eclipse thing, how there's actually more than 12 constellations that actually hit the ecliptic. So as you can see, if we add up all these degrees, we get 360 degrees. And so in doing so, the amount of years it takes for precession should be 360 degrees, right? So with respect to all of that information, I created this little chart. So as you can see, we have age lengths as well. And then we just kind of started basing everything off of basically the cusp between Pisces and Aquarius. So that's the closest date in between the two ages that we would know right now. So basically I based all the start and end dates off of where Pisces and Aquarius meet, which is the year 2595. So there has been some speculation and some guesses and stuff like this, but in the end, from what I've seen, this is the most accurate date out of all this, so I kind of based it all off of that. So with all that being said, let's jump back into this map that we have of the North Star traversing through this night sky. So now I've inputted all these dates into this diagram, and so it's now a little bit more correct, just because each age is not going to be the same. Each age is going to take a little bit longer than the other, and But I also have Ophiuchus in here now, which is kind of skewed it even further, obviously. Well, not really, it kind of took up most of Scorpio's space anyways, and so we have made it look a little bit more accurate with everything being in there. So if you follow it, this is going to be a more accurate set of dates for when the North Star is going to be hitting these points.
Now we can finally talk about Sidereal. So Sidereal Astrology, also known as Vedic Astrology, is based on the position of the fixed stars relative to the Earth. Sidereal Astrology is commonly used in India and other parts of the Eastern world. Now the major difference between Sidereal and Tropical is just the time. We'll have sidereal time, which is the measure of time based on the rotation of the Earth relative to the stars, and it is defined as the time it takes for a particular star to return to the same position in the sky. Sidereal days are approximately 23 hours, 56 minutes, and 4 seconds long. This is slightly shorter than a solar day, which is your typical 24 hours. In terms of time, both sidereal time and tropical time have their own applications and advantages. Sidereal time is useful in astronomy and celestial navigation because it allows for precise tracking and observation of celestial objects, such as stars, planets, and so on. On the other hand, tropical time is based on Earth's orbit around the Sun and is closely tied to the seasons. It is used in everyday life, calendars, and most civil timekeeping systems. Tropical time is aligned with the Sun's apparent motion across the sky, making it more relevant for agricultural activities, weather patterns, and seasonal events. Sidereal time is less than a year, while Earth's orbital period around the Sun is approximately 365.24 days. The difference between these two time periods is due to the precession of the Earth's axis, which is the slow leveling of the Earth over a period of, 26,000 years, as we've discussed many times before. As a result, a sidereal year is about 20 minutes shorter than the tropical year. This means that over time, the vernal equinox appears to shift backwards along the ecliptic, moving it slightly earlier in each successive year. The fact that these two are off means that tropical has been off for a while, and it is rumored that the elites withheld such forms of time/astrology to throw off the masses. Tropical astrology, in the end, creates charts from a chart, sort of how creating a copy of a copy will reduce the quality of the copies over time. Nevertheless, these copies have enough information visible of them for you to recognize that it is still a copy of the original. The same could be viewed for tropical astrology. It may not be as accurate as you want it to be, but regardless, it is still astrology. Consequently, tropical astrology and sidereal astrology will never synchronize due to constant precession. Now, there's several other astrologies, however, I won't get into all those other ones. However, sidereal and tropical are the main ones, but you also have astronomical astrology, also known as scientific astrology, which incorporates astronomical calculations and principles such as gravitational forces and other physical factors into astrological interpretations. It aims to combine astrology with scientific understanding and knowledge. Now, there's also real sky astrology, also known as observational astrology. It is based on the visible portions of celestial bodies at the time and location of a person's birth. This type of astrology takes into account the actual position of the planets, stars, and other celestial bodies in the sky. In summary, real sky astrology is based on actual observations of the sky. Tropical astrology is based on the positions of the Sun relative to the Earth's equator. Sidereal astrology is based on the position of the fixed stars relative to the Earth, and astronomical astrology is based on scientific calculations and physical laws. Each type of astrology has its own unique approach and strength, and the choice of which type of use ultimately depends on personal preference and cultural background. Now let's look at some pros and cons to using all of them. In terms of pros and cons for tropical astrology, the pros are it's widely used and recognized in the Western world. It is also therefore then easy to find resources and information about. It also can be highly personalized and specific to an individual's birth chart. Now the cons to it is that some people may find it too general or broad, and as discussed, it really isn't as accurate as it really should be, so it may not be the most effective system in the end. And so now when we come to sidereal astrology, the pros is that it offers a different perspective and set of insights than tropical astrology does, than what's typically out there in other words. And then it can be highly specific and accurate when done correctly, and then it's also used in Eastern cultures and traditions. Now the cons may be that it's less familiar and accessible to people in the Western world, and then also some astrologers question the accuracy or effectiveness of sidereal astrology still. Now when it comes to astronomical or real sky astrology. It's based on actual observations and measurements of the sky, so it's a little bit more accurate then and specific, and therefore it's used more by professional astrologers and researchers. And the cons are that it's less accessible and understanding to the average person, and then it can also be a bit time consuming and difficult to master. Natal charts, also known as birth charts or horoscopes, are astrological diagrams that represent the positions of celestial bodies at the exact moments of an individual's birth. These charts are believed to provide insights into one's personality, traits, strengths, weaknesses, and life events. The natal chart is divided into 12 houses, each representing different areas of life such as career, relationships, and spirituality. The positions of the sun, moon, planets, and other celestial bodies within the houses and zodiac signs are interpreted to understand various aspects of an individual's life. And that's basically the definition of your typical chart in the end, and maybe we can go more into depth with that at some point. For the most part, I want to keep it more scientific and more on the science side of it all. Anyways, we're going to progress through it all and go to progress charts. Progress charts are a type of astrology that looks at the movement of planets over time and how they influence a person's natal chart. Progress charts are created by taking the natal chart and advancing it forward in time, usually one day for each year of life. Analyzing progress charts alongside natal charts can help astrologers understand the unfolding patterns and potential events in a person's life as they age. It is believed that progress charts reflect the internal growth, shifts in focus, and external circumstances that influence an individual's journey. There are a few different types of progress charts, including secondary progressions, solar arc progressions, and tertiary progressions. So now let's go over this progress chart I made. Basically, for our first one, we have secondary progressions, and they are the most commonly used type of progress chart, and they involve advancing the natal chart one day for each year of life. This means that if you were born on January 1st of 2000, your secondary progress chart for January 1st, 2024 would be the same as your natal chart advancing 24 days. Now let's move on to the next one. So we're on to solar arc progressions. Now, solar arc progressions, on the other hand, advance the chart by 1 degree for each year of life. This means that if you were born on January 1st of 2000, your solar arc progression for January 1st, 2024 would be the same as your natal chart advancing 24 degrees. Tropical has eventually transitioned to be off by a whole sign presently from sidereal, which is 30 degrees. This means that 20 to 30-year-olds' progress charts can look like their tropical charts. Now let's move on to tertiary progressions. Now, tertiary progressions are a less commonly used type of progressive chart that advance the chart by 1/3 of a degree for each year of life. This means that if you were born on January 1st, 2000, your tertiary progress chart for January 1st, 2024 will be the same as your natal chart advanced 8 degrees.
Now, you're probably wondering what's the main difference between days and degrees? And the main difference is that with days, you're actually advancing the natal chart according to how each planet is actually moving. So you're not averaging anything. However, when it comes to solar arc progression, you're actually advancing each planet by an amount equal to the distance the sun has moved. So pretty much everything is in average moved. However, when it comes to days, at least with secondary progression, it's just how fast that planet has moved that many days after your natal chart. So in the end, I'd say days is a little bit more accurate because it's a little bit more individualistic with all the planets. But with degrees, it's just the average.
Each type of progress chart offers a slightly different perspective on how the planets have moved and how they are affecting your natal chart. It is up to the astrologer to decide which type of progress chart to use and how to interpret the results. Remember, astrology is a complex, multifaceted field, and interpretations can vary among astrologers. For a more accurate and personalized analysis, it is recommended to consult a professional astrologer who can provide detailed insights based on your specific birth chart. So I understand this has been very long-winded and a lot of material. I'm glad you made it this far, if anything. But yeah, we have a little bit more. We're going to talk about the calendar year and how leap years play into it all. And so our current calendar system is the Gregorian calendar system. Now, it was implemented in 1582 by Pope Gregory XIII to better fine-tune the use of a leap year. It did so by changing the typical calendar year from 365.25 days to 365.2425 days, which isn't 100% perfect, but a lot more accurate. So if we go over what a leap year is to start off, they are added to the calendar to account for the fact that a true year based on the Earth's orbit around the Sun is slightly longer than 365 days. You have that 0.24 as well. So to keep our calendar aligned with the seasons, we add an extra day every 4 years. This is known as a leap year. However, this adjustment slightly overcompensates for the true length of a year. So every 4 years, that gives you 0.25. So you have a 0.01 discrepancy now. In order to correct this discrepancy, an additional rule is implemented.
The new rule is that
Years divisible by 100 are not leap years, unless they are also divisible by 400. For example, the year 2000 was a leap year because it was divisible by both 100 and 400. But the year 1900 was not a leap year because it is divisible by 100, but not by 400. This rule helps maintain the average length of a year close to the true length of the season. So in the end, you have this extra rule implemented, so you account for that 0.24 not being 0.25, and so it makes it a little bit more accurate. Now, when the year 2000 happened, the whole Y2K thing happened, this was not the main issue. The main bug, also known as the Millennium Bug, exists because programmers often left out the 19 for the year in an effort to be more efficient with their data storage. This was due to the large cost and space required for early electronics to store data. On top of that, it was not fully understood how some systems would interpret the 00 as their input for the year in the end. The fact that the year 2000 was a leap year may have added to the confusion, however it was not the direct cause for all the hysteria in the date's infamy. And I really hope you enjoyed this video. I really enjoyed making it for y'all, but I really hope you got a lot from it, you learned this and that, because there's a lot of this stuff I feel like a lot of people just don't know, the average person doesn't know. A lot of people don't know what the celestial sphere is and how our calendar really works, and a lot of those intricate things, all the moon phases, and a lot of it I feel like isn't really known information. I hope you enjoyed listening to it and learning from it. Yeah, and if you enjoyed the astrology portion, I hope you enjoyed that then a lot. So I definitely try to give it my all with dealing with precession and everything, and hope you understood a little bit more about sidereal and everything. And I don't know, I just really enjoyed doing this topic for you all. I hope to see you next time. So make sure to keep learning.